All right, welcome back. This is part 2 of CIT15 week number 3. And in this video, we are going to take a look at PowerPoint presentations. And we're going to start off with, we already saw this. That's what we learned last week. We're going to jump into my week 3 slide, and then we'll jump into the PowerPoint chapter 3. So I just want you to kind of see what hard disk drives look like. Like there's the hard disk drive. And if you cut that open, you find this inside. And if you look closely at it, there's actually, like, even though you think about your hard disk drive as just like one thing, like, oh, it's one big disk, there's actually like 3 platters in there on this one, and they're writing to the top and the bottom of each platter. So the way that looks physically is like this, but logically the way we see it is one drive, right? But anyhow, there's that moving part. The read-write head will move back and forth across those platters, and that is a breaking point, because if you drop your computer, that could hit, those little read-write heads could hit the platter and damage the data, or they could break. And solid-state drives don't have that moving part, which makes them more robust. There's another picture of a hard disk drive. I'm going the wrong way. And that's kind of like how close the read-write head is to the platter. So there's like a human hair or dust particle or smoke particle, and the head of the read-write head is like super close, right? You kind of see that. And then here is like, what it does is it's kind of creating negative and positive charges, to represent either a 0 or a 1. And it also kind of like breaks things up into chunks. And so, those are representations of like, it has little cubby holes basically where it stores stuff, and then could go access stuff from those cubby holes. And then, more so in the past, hard disk drives could get fragmented, and not so much an issue today. Computers pretty much take care of themselves today. They're pretty amazing. But in the past, you could run like defragmentation. So if you've ever heard of that, the data might get stored all over the place, right? But you could type in defragment and optimize drive. So I just typed in defragment. And then you could analyze your drive, so if I bring this over, I could say, hey, analyze this, optimize, and it'll like defragment it. So if your computer's running slow, you might do that. Maybe it'll speed up a little bit. And that was all secondary storage magnetic. Here's secondary storage optical. So optical is like a laser shines at a CD or a DVD, and whether or not that laser bounces back or not, given a certain, little section, that's a 0 or 1. So it's all about on or off, 0 or 1. And the way we get that with DVDs or CDs is they're reflective, and the light gets bounced at it. And sometimes there's a place on that CD that absorbs the light just passes through. And sometimes it bounces back as if it hit a mirror. And so if it goes through, that might be a 0, and it bounces back, that might be a 1, right? And so those are like called pits and lands. So it looks like the land is the shiny part here, and the pit's the part where it doesn't bounce back. That's how we get the 0s and 1s with optical CDs and DVDs. And then we have secondary storage, flash or solid state. Those are like thumb drives or SD card, secure digital card for your camera. And, we've all seen those, and that's kind of what they look like inside. They have a little chip inside. It's solid, right? It's no moving parts. And so a solid state drive also is kind of like those thumb drives, so it just has a whole bunch of those little chips inside. There's smoke in the air. Wow, man. You can kind of see there a solid state drive versus a hard disk drive. The hard disk drive has moving parts. And then, just kind of looking at input and output devices, the 4 functions of a computer, right? I/O. There's kind of like breaks down, like categorizing the different hardware pieces as input, output, storage, processing, device. And I guess communications is thrown in there. I don't know why. You could think about those like, are they input or are they output? They're kind of doing both. And then, like a keyboard, ergonomic keyboard, kind of, instead of your wrist having to go like this to be at a flat, straight keyboard, you go like that, right? So your wrist isn't in that weird bent angle. So it could be a little bit better. And ergonomic was the word I used there. And then the mouse, and you could read that if you're not sure about what right clicking is, or dragging and dropping, or the scroll wheel button, or you can watch a video on YouTube. I'm sure somebody has one about how to use your mouse. And then scanners, another input device, scan stuff, get it into your computer. Like old Scantron tests, right? Like the computer's going to read whether or not a mark's in one place or another place. and score it. They could recognize handwriting today, checks, those little magnetic things at the bottom, those numbers. Let those numbers be scanned in. Barcodes are a way for scanning. RFID is kind of interesting. It's like a little chip that could be put into stuff that broadcasts a unique identification. So it's radio frequency ID. And like if, everything at a store had those in them, they're about 7 cents a piece. So retail doesn't want to lose that for each item that it sells. But if everything in a store had an RFID in it, you could just like walk through a scanner, push your grocery cart through the scanner, automatically know everything that's in the cart and say your bill is this much, right? So they wouldn't have to scan each barcode, but they're like expensive. And there's an interesting little commercial. You could YouTube that, IBM RFID commercial. It's really old, but you can check it out. So Bay Area Fast Track is an example of RFID being used. Or pets get little RFID chips in them. So if you lose your pet, they end up somewhere, they'll scan your pet for an RFID chip, and then they could figure out, who you are. Farming uses them. And then there's biometric scanners, biology, metric measure, so measuring biology, biometric, that's what biometric stands for. So that's, they're measuring thumbprint, fingerprint, retina, facial scan. Like facial recognition's amazing now. Holy majoli, you load up pictures into Google Photos and then they could identify who's who in what pictures. And when you look for cameras, so that's kind of, I'm just going to skip over cameras. So that's kind of like, there on speech recognition, you could click that little microphone and talk to your computer to do a search. It's kind of cool. And then we have output devices like monitors. And so old monitors are made up of little dots called pixels. And so pixel is a picture element, and that's what it stands for. So let me draw you a picture of monitors so you get this terminology. Okay. There we go. Perfect. So the monitor, right, we have some sort of an aspect ratio. So that's should be like a rectangle, right? Or you have the old, just it's a square. That's not quite a square. More like that, like that's old school aspect ratio. So the aspect ratios, what kind of a shape is it? And so some common aspect ratios would be like, 16:9. So for every 16, like 1, 2, 3, 4, 5, 6, 7, it goes 9, right? So it's wider than it is tall. And so that's aspect ratio. And what these little dots are picture elements. They're pixels. And so literally the way an image gets made on a screen is it's a whole bunch of little dots. It's a whole bunch of little dots. And those little dots can be different colors. They're like, it's amazing. So it's kind of like this. And art, pointillism. Pointillism. Okay, and if we look at images of pointillism, like, I don't know, which one do we want to look at? Like this one's pretty cool. So this image is made up of a bunch of dots. And when you look at it from far away, it just looks like an image, right? Yeah, but when you look close, it's made of dots. Same with computer screens. Like look at this image, right? Here's the image, but if you look at it up close, it's made of a bunch of dots. Okay, so if you got really close to this, you just see a whole bunch of little dots. And I don't know if we can zoom in on that. Give it to me big. Like you're starting to see the little dots. Anyhow, right? Those little dots, that's a movement in art, was to create art with little dots. And that was called pointillism. And the main point here is that just like artists made paintings with dots, and they, are coherent images to our eye. So too it is with computer screens. And we add in enough dots, and we start to be able to make an image. And so resolution is how many dots do you have? And so you might have 1920 by 1080, right? Which means that you have 1920 this way, and you have 1080 that way. And then you fill in all those rows, right? There's going to be 1080 rows, and there's going to be 1080 rows, and each row is going to be 1920 pixels, and there's going to be 1080 of those rows, right? And so eventually you just get all these dots, and then these dots can be different colors. Well, back in the day, let's say we have 1 pixel. So if we have 1 pixel and we want that to show color, then we need, it's like it doesn't focus on the screen when my face is there. We want that to show color, right? If we have to store that data. What color should that be, that dot? And we have to store that for each one of these dots, right, to make an image. And so let's say we're storing 1 bit to represent that color. And so that's called bit depth, or color depth sometimes, right? But what, there you go, you see it? Come on, focus on the board. There we go, that's better from back here. So that's the bit depth. And so the bit depth is 1. And if we have 1 bit, it could be on or off, which means we could have 1 of 2 colors. And so it could be black or green. And if you look at old computers, when they couldn't store as much stuff, and they couldn't process as fast, right? Old computer screen, black, green. And I mistyped that. But here we go, right? Like these are the old computer screens. They were just black and green because every pixel was, could be black or it could be green, because each pixel, they only were storing one bit. They were storing 1 bit, right? 1 bit per pixel. And so what's that old Donner's Pass game? What's that old game? Old wagon computer game. What was it called? Here it is. Right? Oregon Trail, that was it. And you could actually see here the pixels, like they couldn't get that smooth, right? There's like jagged squares here. And same with the letters. It's kind of jagged. And this, whatever that is, bull or horse, right? It's jagged because the pixels are pretty big. And so that's the way that worked, right? It wasn't high enough resolution. It didn't have a high enough bit depth. But now we've got really high resolution, and we have really high bit depth. And so if we had 2 bits, right, with 2 bits for our bit depth, we could store 4 colors. And if we had 3 bits for our bit depths, each pixel could be one of 8 colors. We could say, oh, this pixel is going to be that color or this color. And so if we look at like bit depth wiki, bit depth, and there's, audio's, oops, here, let me bring this back up. Audio is the same way. So there's bit depth Wikipedia and audio bit depth, right? Because for each sample in audio, you could also do it. And they're calling it color depth. And so, yeah, that's the right phrase then.
Change user.
What? Was that Alexa?